So today we will see a sort of a small Python implementation of a perceptron neural network. So obviously this will be exclusive in today's session, and I will repeat the same on tomorrow morning 11 o'clock. So this part will be very exciting because we will not only understand the concept, we have also discussed some sort of understanding we have regarding artificial neural network. And now, at the end of today's session, we'll discuss thoroughly a small implementation of artificial neural network, particularly perceptron, uh, for OR classifier, or Boolean logic or classifier. Okay, so we'll see. Already 47 students have joined. So I want to wait for another 2 to 3 minutes, then we'll study. We'll discuss. I remember last day, few students, including girls, called me and apologized for their post in the public chat box. So please do not repeat such thing because this is already recorded and recording is also going on, and we are submitting these links to KIT authorities. So do not indulge in any improper behavior. Okay, so we are going to start this session. So today's topic is regarding artificial neural network under the artificial neural network module, and the topic is perceptron learning. So this is our agenda today. Agenda is kind of quick recap, and then artificial neural working model, again a kind of a revision, a brief revision, then back propagation. What do you mean by back propagation? Perceptrons learning, and or perceptron classifier and implementation. This is very exciting and important. Also Python 3.6 implementation of or perceptron classifier. So let's see, we have discussed this diagram, we have seen this diagram many in my previous classes. So what happens, these are please follow my cursor. So these are x1, x2, x3, xm, these are all inputs, also written here inputs. w1, w2, w3, wm, all these are weights. Okay, and this is summing unit. You can also say this is another neuron. So these are the either these inputs come from environment directly as input, or these inputs can be output of some other neuron. Okay, so this may possible. So what is a summing unit? Now in case of summing unit, it is very simple. This is a sum of products, that is weights multiplied with inputs plus bias. So the bias is not means drawn here exclusively, but it is already within this mathematical expression of sum. So wi and xi, I runs from 1 to m. Sometimes also we include w0, weight 0 for that, and we'll see. But just for a quick recap, this is a neuron model where these are the inputs, these are the weights, this is summing unit, very important one. But this is not the output of this summing unit is not the result. We need to pass this sum to an activation function, and this activation function gives us the actual predicted value, and that predicted value sometimes indicated using y hat. So y hat actually the predicted value output, and here in this example we have actually used step function. Okay, we have used step activation function. So this is very important. And what happens in step activation function, if you remember from your previous session or your last day course material, this is very simple. If the in step function, if my sum value greater than equal to 0, it will be mapped to 1, otherwise it will be 0. So it is already written in this rectangle box. And also the pictorial representation of an activation function of step function is also given here. Now, again same thing. This diagram is a kind of multiple inputs and one neuron as output. Then again, this is input layer. Yes, in this case, in top left diagram, what happens? There is no hidden layer. Okay, so this is single layer perceptron. So this is an example of single layer perceptron. And if you move to this side, that is top right, then you see there is inclusion of another intermediary layer, and that layer is known as hidden layer. So this is a kind of a new for us. So this is single layer perceptron, and this is perceptron with hidden layer, also known as very popularly multi-layered perceptron. Okay, so this is the starting of multi-layer perceptron in our syllabus. So this is single layer perceptron because all are inputs and only single neuron is as output. But in this case, there are multiple hidden layers. In this example, there is only single hidden layer, but you can also add multiple based on your requirement and problems. Now, just to understand how this multi-layer perceptron works, though in our syllabus and also our focus mostly as our syllabus covers the fundamentals of ANN, so our obviously our focus will be single layer perceptron, and using single layer perceptron we'll try to solve small problems like OR classifier and classifier. I will show you one example OR classifier today. So in case of multi-layer perceptron, what happens? So in multi-layer perceptron, if you consider this diagram, then there are 3 neurons in the hidden layers. So H11, subscript 1 and superscript 1, it means this is the first hidden neuron. So what I mean, that is, this is the first neuron of the first hidden layer. As there is only a single hidden layer, so it is obvious. So W11, W22, WM1, and the capital W1, it suggests that this is a vector, weight vector. And these weight vectors are actually associated with all the inputs and the first neuron of the hidden layer. Similarly, W2 capital, this is a weight vector. And what is it all about? Now, this is a weight vector associated weights for the second neuron of the hidden layer associated with all the inputs. Similarly, if you consider this as the last one, Wn or W3, then this is a weight vector which is associated with all the inputs and to the last neuron of the hidden layer. Okay, so ultimately, in case of multi-layer perceptron, weights are nothing but, if you concatenate them, then these are nothing but a kind of a matrix. So in case of, remember one thing, that in single layer perceptron, weights are a kind of a vector, whereas in case of multi-layer perceptron, you add another layer in between input and output, then these are nothing but a kind of matrix. Okay, and this is the common understanding of the diagram. Now, this is very important. We are discussing today multi-layer perceptron and back propagation technique. This is important for our NSEM exam also. So what happens in multi-layer perceptron and back propagation? I am just reading it out. Back propagation, a procedure to repeatedly adjust the weights. We will see this in with example using Python. But before that, we should understand the concept. So a procedure to repeatedly adjust the weights so as to minimize the difference between actual output and desired output. So this is a part of supervised learning. Many of you already done some sorts of projects or intensive or online courses. So supervised learning where we have to map inputs to a target, and we have to develop some sort of function. Using that function only, we have to map the inputs to the target. So what is the prime aim of focus of the backpropagation? Now backpropagation gives us some sort of technique through which we can adjust the weights, and after adjusting the weights, what will happen? Now it will minimize the difference, the error in between the actual target output and the predicted output. So desired output means the actual one, and the predicted means what we are getting from the model. And hidden layers, these are also new now, which are neuron nodes stacked in between inputs and outputs, allowing neural networks to learn more complicated features. So I have already explained the very first day of ANN, that is linearly separable problem, non-linearly separable problem. So in case of linearly separable problem, that means using a single line, you can separate or segregate multiple type of, or at least a binary type of objects to different type of objects or entities. So those are known as linearly separable problems. But in case of a non-linearly separable problem, what happens? A single line cannot segregate or differentiate between a group of objects. So we need much more complex decision boundary. The technical term is decision boundary, to separate different type of objects. In 2D plane, these are known as kind of a hyper plane, and okay, so in higher dimension, this is known as hyperplane. So the first understanding of a nonlinearly separable problem is XOR logic. So if you remember the truth table of OR and XOR, so in case of OR and AND, it is pretty simple. So using a single line, you can separate two set of outputs. One is true, that is 1, and another one is 0, that is false. But in case of XOR, if you observe it closely, 0 1, in case of alternate input, it always gives us true. Otherwise, if the inputs are similar, 0 0 or 1 1, it always gives us false. So in that case, we cannot classify these inputs or this type of inputs using normal linear perceptron. We need multi-layer perceptron. Okay, so this is backpropagation and multi-layer perceptron, very important for exam also. Now this is the pseudocode for supervised training. Just go take 2 to 3 minutes and go through by yourself. I am not reading it out. This is very important because this is the pseudocode we have implemented using Python 3.6. So if you understand this mechanism or these steps clearly, then you can easily relate this pseudocode to the actual implementation of OR perceptron classifier. Okay, so first take 2 minutes to go through supervised training, the pseudocode 1 2 3 4 5, and also then move to the kind of detailed perceptron learning rule that is right of the screen. Okay, so take 2 to 3 minutes, just go through it. One is pseudocode for supervised training. It's a kind of a broad and abstract kind of thing, and the second one is kind of detailed, that is also known as perceptron learning. I have already given the detailed example in also in during one class, that is convergence, perceptron convergence algorithm. So those who have attended the class, they have written it. So otherwise, they can. I will also share this like the last session. I will again share the PDF of these slides to you after the end of these two sessions. One today, and another one, the repeat one in tomorrow 11 o'clock. After that, I will share this, so you can go through and you can search by yourself. Okay, so this is very important, and I hope you have given enough attention to these two pseudocodes so that we can easily understand the concepts uh, during implementation of or perceptron classifier. Okay. So this is again the same thing. What happens here? There is a kind of delta y hat and delta w. So that means using this backpropagation technique, we will find out the error, the difference, either using different type of different type of activation functions. So in this diagram, it shows that using sigmoidal function as an activation function, this delta w will be calculated, and after that, this delta w will be added to the previous weight value, and the new weight value will be calculated, and again we will repeat the same step, that is input into weights plus bias to calculate the sum, and then sum value will be again feed into the activation function, and this process will repeated by itself until unless our predicted output becomes the desired output, at least close enough. Okay, this will be the convergence criteria. So there are popularly two technique of convergence technique. One, either for last k number of iterations there is no improvement, so you can early stop your early convergence, and another one is the error. If you find your error is too little, that is 10 to the power minus 6 or something between the target, that is the desired output, and the predicted output, then you can also stop. So there are two major rule to stop your algorithm, either after for last k iteration there is no improvement, another one is the error is too little. Okay. So this is our perceptron example. Go through it. This is or truth table is there. The classification model is also, the diagram is also there. So this black dot represents the false case, that is the false output, and the rest of the all these white circles, small bubbles, are actually representing all the true outputs. So as you can see, I have already stated that in case of or and using a single line you can classify them, you can segregate them, but in case of XOR you cannot. So I am showing you how you can create your own or classifier or perceptron classifier. So this is our model. We have two inputs, that is x and y. These are inputs. We have two weights, w0 and w1, and also we have assumed, for sake of understanding, easy understanding, that bias is also another input. So yes, bias is not logically or technically, it is not a kind of input you per se, but for our understanding of the equation in more simplified form, we are assuming that b is also a kind of input and w2 is the associated weight. That means the sum function will be, the sum k function will be x into w0 plus y into w1 plus b into w2. Okay, and this sum value, whole value, will be feed into this activation function, and then the output the prediction will be done, and based on this prediction we will see whether this predicted value is similar to our desired output. If not, then error will be, difference will be calculated, and then we will change that w's weights to delta w. Okay, that is the changes, and by updation, by modification, this process is known as backpropagation. As we have already discussed this in last slide, we will modify our model. Okay, we will improve our model. So we have used two examples. First one, using step function. What is step function? Now if my sum k is greater than equal to 0, it maps to 1, otherwise 0. In case of sigmoidal, we know the z, 1 minus 1 plus e to the power minus z, z will be the sum k value. It is already the equation is also there, and also what is z, that is also given. Okay, So now we'll move to implementation part. So we have reached the last portion of our today's lesson, that is very important, real. So as an engineer, always we seek implementation and real world application, a kind of a sort of outputs, so that we can relate. So here the job is to create a kind of model classifier which will classify any sorts of inputs based on OR classification of technique. Okay, that is for 0 0 it will be 0. So values which mimics or represent or tends to zeros always gives us 0, otherwise it will always give us 1. Okay, so we'll go through this code very quickly. So as you can see in this particular share, this is Jupyter Notebook, Python 3.6. We have imported some packages, NumPy, Random OS, and we have two constant. One is learning rate, that is 1, and bias. We know bias, a kind of offset, and this is 1 also. Okay, so bias and learning rate both are 1. Now we have created, as we have 3 inputs, actually 2 inputs, x and y, another one is as bias, but we generate 3 random values, and using those random values we will start our modeling technique. So that will be the initial random weights. So using random function, we have created weight vector, and then we have printed the weights just to see what is the output of the weights before training. We have printed this. Then what happens now, I will come to this part. This will be our function. So before discussing the function, go to the training part. So iteration, we have trained our model 50 times, and these are the samples. These functions are our samples. What is the function? Now 1 1 gives us 1, 1 0 gives us 1. So what is the argument list of the or parameter list of this function? The input 1, input 2, and the desired output. And for 2 input truth table, obviously it will be 4 cases only, and we have repeated these samples for 50 times. This is our model which repeated 50 times. That means the weights will be tuned for 50 times, so that our predicted output will be similar to the actual output or the target. Okay, the error will be minimum or minimal. And then we have created this user defined function known as perceptron, where the argument is input 1, input 2, and output. Then what happens in output? This is very simple: sum of products, input 1 into weights, input 2 into weights, and bias into weight. So obviously weight has 3 values. So weight 0 signify the first weight, weight 1 signify the second weight 2 signifies the third weight value. Okay, and this ultimate sum k, this output variable, is nothing but the sum k, summing unit. And then using the hard limit, that is the step function, step activation function, we check whether the output is greater than 0. If the output is greater than 0, then our prediction is 1, otherwise the prediction will be 0. Okay, and then what happens? The very important back propagation part, we check whether the output and the actual output, and that is given here, and the prediction, okay, that is the predicted value, whether there is a difference or not, that is the error. And using that error and the learning rate, that is LR, we are updated the weights. So okay, so each time in each iteration these weights will be updated, and after that, after 50 iteration, what happens, we will have a kind of weights which will be suitable to classify any two inputs based on the OR classifier or truth table. Okay, so we will then again testing part is very important. We will take two inputs, float values as input, and we will print the weights, and also again calculate the sum value using that unknown inputs x and y. Then we will use those weights. Those weights means the weights obtained from the training process, 50 iterations. Okay, tuned weights, and expect anticipation is that, and expectation is that our output will be as per the desired output. Okay, this is the expectation. So see, we have already 10. Now I am running it. So okay, so input. So suppose I am taking a value 5 and another value as 0. Okay, see what happens. Now before training the random weights, these are random weights using random function. Then I have given 5 and 0 as unknown input. So our model learn 1 1 1 0 0 1 0 0. Okay, but I have given unknown weights. This is the real case scenario, test scenario. And after 50 iteration, our model learns if we want to mimic this truth table, the initial weights that is generated randomly needs to be changed into this set of weights, and using this weight you can see 5 0 gives us 1. So yes, it is true because 5 is a true value, very positive, and 0 is 0. So 1 0 or any positive value and 0 always gives us 1. Okay, this is our scenario. So you can also see some other cases, like I am giving -2 and -3. It is 0. See, so this sum, this test sum, see closely. This is the sum output, summing unit of the unknown test set for -2 and -3. And using the step function, that is output is greater than 0, it gives us the result. Okay, so now we will again repeat the same thing, but not using step function. Rather now we will use sigmoidal function. Okay, see, very simple. So previously we have used if else kind of conditional statement to mimic the step or hard limit activation function, but now we will mimic the sigmoidal activation function. Okay, so now the equation is only changed, rest of the things remain same. And if you run the same thing, that is -2 and -3, see, it gives us 0, it is true. And if again we run, and suppose this time one is 5 and another one is suppose -1, see, it gives us 1. Okay, so these are the output and these are the training. So now the thing is that this model learns based on number of iterations. So let's see one or two cases where they are not very good in predicting the outputs. Okay, so first we start with one iteration. So one iteration will help us to understand whether it works quite well or not. Let's see the test case scenario, that is 2 and 0. Okay, so we will check this for 2 and 0. So now the input is fixed, and we'll see what will happen. Okay, let's see. So before training, the random weights are these. These are the random weights, and then it enter into training process, and we have fixed our training process as one only, so that we can understand the change. So random initial weights, or initially the weight vector is 0.05264, 0.1747, and 0.8087. But after the training process, what happens? There is a slight change in the weight, in the last weight value, that is weight 2. 2 is the index. And after one iteration, what happens? We use this set of weights because this is the ultimate or final weight update. So this is our updated weight, and using that weight for 2 and 0 input, it gives us 0. Now in case of 2 and 0, it is true. 2 is positive value, 0 is 0. So any positive and 0 should gives us 0. So this is truth table, okay, or truth table. But now we take some other example, okay. Let -2 and 0, okay. So see, in this example, what happens? 2, 0. So 2 is a positive value and 0 is a kind of 0 value. So it should give us 1, because in case of odd truth table, 1, 0 means 1, or 0, 1 means 1, 1, 1 means 1. So we can observe that a single run of the training cannot give us a set of weights by which we can classify these two values 2 and 0 properly. So we can move, or we can increase the training number from 1 to 2, and let's see what happened. Previously we run our training model once only, okay. Now what happens? We run it for another time, twice. And after the second run, now we obtain a set of weights by which we can find that for our input 2 and 0, it gives us 1. So from this very example, you can see that yes, backpropagation technique works in reality, and trainings iteration, it is playing a very important and crucial role in the training process. So today's session we have discussed backpropagation, multi-layer perceptron, how it works using example in real world code. And as from this example you can see that for a different unknown set of inputs, we can also classify based on a proper training model, okay. So if you have proper training model, then only you can also test the unknown cases. So this 2, 0 is unknown to the model, because our model only learn 1, 1, 1, 0, 0, 1 and 0, 0. Okay. So now sir, your voice is not audible. Hear your voice. Hello. My voice is audible. I have unmute all of the students. If you have any issue, you can ask me, okay, or you can write me in the chat box. Otherwise, I will end this session.
Sir, audio is not audible properly.
Okay, that may be the internet facility problem, but I will share this diagram and this slide. So